Hello, my name is Mike Avery from Cadence Design Systems. In this video we're going to talk about global clocking and the changes in behaviour which have been observed over the last few standards. So we're going to talk about this in the context of a design with some hierarchy. So you can see here that there's some hierarchy being created here just to give a demonstration of a hierarchical view. And let's look inside one of them. So Lev 2 mod, you can see the module name next to the instance name here. There are several instances of this in this design. So let's just go and look at one of them. Before we talk about global clocks, what we'll first do is make sure we understand what default clock means. So in this module that we've looked at in the hierarchy, we happen to have some assertions which do not have a clock associated with them. This will be a syntax error. The System Verilog language reference manual requires that every property has a clock from somewhere. So if I do not put an explicit clock in this property definition, then what it means is I'm relying upon a default clock definition. So here we have one. So the default and clocking are keywords. That name my def clock is a name I make up, and at postage clock defines what that default clock is, and I need this end clocking keyword to end that construct. So this forms a clocking block, and if I look into the hierarchy here, I can see this clocking block just there. Okay, so if I were to send that to the source browser, I'd be back at that definition. The important thing about this default clocking definition is it only applies to this scope, namely inside of this module. It does not apply to anything else. So that default clocking definition doesn't apply to, for example, one of these Lev 1 mod instances or the top level or any other place in hierarchy that has a different module name. It's only modules which are Lev 2 mods which have this default clocking definition. If I wanted the same default clocking to apply in every level of scope in this design, I would need to have a default clocking statement in every single different module I had in here. Okay, so default clocking is not the same thing as global clocking. Global clocking is something different. Let's go back to the Lev 2 mod source code. Okay, so you can see here my default clocking definition. Global clocks, as I've said, are not the same. They apply, as their name suggests, globally. So if I were to type the keyword global there, that is legal syntax. So I could delete that as well. That's an optional thing to put there. So once I've done that, I've now got a global clocking block. Now that doesn't get around my problem of not having a default clock. So for these properties here, I would have to specify I want to use the global clock by doing this. So I literally need the name $global clock. So that's a system call I can use anywhere in the System Verilog hierarchy, including levels above it or below it or at the same level. So I also would need the same definition if I wish to use the global clock for this property here. So if I wanted to then, being as I have this global clock definition here, I can go and use this in some other module. So if I have some other assert at some different level of hierarchy. This is a Lev 1 mod instance. So if we just look at the hierarchical viewer, we can see this is a level above where I've defined my global clock. And the same would apply if I was doing this at the top level, by the way, as well. I can also say the same thing here. Because it is a global clock, I only define it in one place, and I can use it or access it rather via a system call to $global clock anywhere else in the hierarchy I wish. Now this is the situation if you're using the 2009 language reference manual. That's the IEEE 1800 standard for System Verilog version 2009. That's how it works. So in that standard you're only allowed one global clock definition in the hierarchy. If you define more than one, then that is a syntax error. In the version 2005, the first version of the System Verilog language reference manual, global clocks weren't defined at all, so that would have been a syntax error because it wouldn't have known what global clocking was or what $global clock meant. Things changed, however, in the 2012 standard, and what changed in the 2012 standard is also restated in the 2017, i.e. there was no change in behaviour, is that you can have more than one global clock definition. So now, if I were to go back to this Lev 2 mod, if I were to copy this global clock definition and go and put it here, for example, this definition applies to anywhere in the hierarchy from this position in hierarchy downwards. If I make this something different, so that the clock has the same name, but if I use a different edge, for example, so we can see there's a difference between the two definitions of global clock. So the properties at this level are using the global clocking definition at this level, but when I go down to level 2, I am no longer using that level 1 definition, I'm using the level 2 definition. So if we look at how this looks on the hierarchy, level 1 is using its level 1 global clock, level 2 is using its global clock. So this leaves us a problem. What if I have defined a assertion in the top level which says $global clock? Which one does it use? Well, the answer is neither of them. So how it goes when you use something like $global clock in a property like this, how it resolves which one to use is either the one that's local. If there is not one present local, it goes up in the hierarchy hierarchy, i.e. only in one direction. It goes up towards the top level, and it uses the first global clock definition it finds. And in this case, if I had not defined any global clock at the top level and I'm using $global clock at the top level, there is nowhere to find the definition of one of these global clocking blocks. Therefore, that will be an error. So if I were to go to the top level and I was to write some assertion in here using $global clock, that would be a syntax error. So that's the definition in 2012 and 2017. Just to state what the use of global clock would be, as we've seen, global clock definitions apply to everywhere in a hierarchy, i.e. from some parent downwards, and it might be useful, for example, for different subsystems to have different $global clocks, which is why the language reference manual changed in 2012. Now, the global clock is something we can define somewhere else without having to know at the time which clock do we wish to use. All we know is we're going to use some $global_clock, which we will define later. So we could define it later, for example, in a parent of the module where we know where we're going to instance it. So we don't need to know at the time of writing the property what $global clock actually gets connected to. We can make that definition later without having some explicit connection running through our hierarchy. So I hope that clears it up for you. So the summary of this is use $global clock if you wish to have a clock go everywhere without needing to have a hierarchical connection all the way through. Be careful which version of the language reference manual you're using. In the 2005 standard it didn't exist. The 2009 standard you're only allowed one global clocking block definition in the entire hierarchy. From 2012 LRM onwards, so that's the 2012 standard and the 2017 standard, you're allowed as many definitions as you like, and the way in which it resolves which one it uses is by using the one which is at the same level of hierarchy or the one in one of its ancestors. If we find a use of $global clock with no existing definition in the local scope or in any ancestor of it, i.e. higher in the hierarchy, that is defined as being an error. Okay, so thanks for watching. Hope you found that useful, and goodbye.